Okay, good morning. Happy Friday. It's going to be a good one. Morning. How's the week going? Make it through all right? Relatively so, I guess. Well, I'll take it. Not too much left here. Not too much left in the entire school year, I suppose, actually. Didn't get much done. Hey, as long as you're getting some stuff done, putting in some amount of effort, can we call it pretty good? I think so. At least given the current situation. Yeah, so it's fine. Just keep on keeping on. Okay. Well, let's go ahead and start off our last unit, matrices. Right? Yeah, it's kind of crazy. We're down to it. Right? We just have some stuff to talk about with matrices. So we've already briefly we talked a little bit about what a matrix is. When we were solving our systems, and I taught you guys how to solve the systems of equations using your calculators, your graphing calculator. And we put all those numbers, in like a box thing. It's a matrix. Okay. So we're going to learn some more stuff to do with matrices and some more complicated things and things that we can work with. But matrices are super useful. So a matrix, a collection of values, arranges, maybe not. It's off to a good start. Let's say arranged in rows and columns. We will write like this mxn, which we read as m by n, right? That's what we call the matrix. It'll depend on how many rows there are and how many columns there are, like a 2 by 2 matrix or a 3 by 5 matrix or, whatever. So, let's say this is a matrix. So there's 2 rows by 1, 2, 3 columns. All right, so we would call this a 2 by 3 matrix. The position of the values are denoted by A sub ij. I represents the row position, j is the column position. So that's if I want to talk about like a specific value, like if I want to talk about this specific spot, right? Well, how do I do that? Well, I use this notation a and then the row number that it's in and the column number that it's in. So, for example, 3 rows, 4 columns. So we would call this a 3 by 4 matrix. And let's just practice using specific spots. So if I wanted to know, hey, what is the A24? So it looks like 24. It's not 24. It represents 2 represents the column, or sorry, the row. So the second row and the 4th column. So that spot is -7. That's where -7 is. All right. Or if I wanted to know A12, so I go to the first row, right? That's what the 1 represents, is the row number. And then I go to the second column. So that spot is where the 1 is. Or let's say A33. So I go to the 3rd row in the 3rd column. That's where the 4 is. All right, so we can pick out specific values, specific spots in the matrix by here's the row that it's in, here's the column that it's in. Where do those hit? Great, that's the number that I'm talking about. We can do lots of operations with matrices. So for example, we can do matrix addition and subtraction. A couple things though. In order for this to work, the matrices must be the same dimensions. Okay, they have to be exactly the same in terms of the rows and columns. We can only add and subtract if they're the exact same. And so how do we actually do it? We just add or subtract values from the corresponding positions in each matrix. So it's pretty intuitive of how you would think it would be. We just kind of match up the things that are in the same spot for each matrix and add those together or subtract those together. But again, really big emphasis. Same dimensions. Okay. So, for example, let's subtract these 2 matrices. All right, so first, I have to double check before I add or subtract that these are the same dimensions, same size. So 3 columns, or sorry, 3 rows, 2 columns. So this is a 3x2 matrix. 3 rows, 2 columns. So this is also a 3x2 matrix. Okay, so it checks out. I can actually add and subtract these together. If they were different sizes, I couldn't do it, but they are. Right, so what does this equal? Well, we're just going to subtract things that are in the same spot, right? So 3 minus 2. Great, so that's 1. That's what goes in the first spot. -12 minus 1. -13, so that goes in that spot where those were. -5 minus 1. -6. 4 minus 7. -3, 2 minus -1, +3, 8 minus 8, 0. Whoa, bit diagonal. So there's my answer. Again, it's pretty intuitive. Just match up the spots, add those numbers together, or subtract those numbers. And that's what goes in that same spot for the new matrix. But all predicated upon that they're the same size, same dimension. We also have what's called scalar multiplication. And what this is just multiplying a matrix by a constant, right? Or another way of saying that is a scalar, hence why we call it scalar multiplication. Right? Because it just scales it up or down. When we multiply by something, we're saying it's that many times bigger. So it's like scale up, scale down. If we do that, my goodness, who made this thing? Take every value in the matrix and multiply it by the scalar. Okay, so we do have to specifically call this scalar multiplication because for matrices we have different kinds of multiplication, right? Which sounds weird. Okay, but we'll have a couple different types of multiplication for matrices. So this is a very specific type called scalar multiplication. And again, this is the most intuitive, where we see a number on the outside of the matrix. We just multiply that number by everything on the inside. It's almost like distributing it to everything. Okay. So for example, it does not matter what size of matrix we have for scalar multiplication. It works with anything. Okay. So again, it's like we just distribute 20 times 6, 120. 20 times 1, 20. 20 times 2, 40. 20 times negative 3, negative 60. 20 times 1, 20. 20 times 4, 80. 20 times 0, 0. 20 times 8, 160. Easy peasy. Right. Very intuitive. It's what you would guess. Okay, so as an example, let's have these two matrices, A and B. And so I have two things for each. I have a scalar multiplication for each, and then I also want to add the two matrices together. Well, remember, before I add these together, I first need to check, if I'm trying to add, I need to make sure they're the same dimension. So 1, 2, 3, 1, 2, 3. So this is a 3 by 3 matrix. 3 rows, 3 columns. So this is also a 3 by 3 matrix, which means that yes, we are allowed. Oh, I guess you guys can't see that. Let me move that over. Or move it down, I guess. Right, they're both 3 by 3 matrices, so we are allowed to add these together. All right, so first I'm going to do the scalar multiplication for each. So I'm going to start with the negative 5 times A. So I'm going to take the matrix A and multiply everything by negative 5. So negative 15, negative 10, negative 5, negative 5, negative 20, 0, negative 30, positive 25, 0. Okay, so that's negative 5A. But now let's do 4B. So that's just the matrix B, scalar, using scalar multiplication with 4. So 4 times everything inside there. 4 times 3, 12. 4 times 0, 0. 4 times negative 3, negative 12. Oops. Negative 4, 8, 20, negative 4, 16, 24. All right. So I did the scalar multiplication. Now let's actually add these two matrices together. So remember, for matrix addition, it's exactly what we think. It's very intuitive. We just match up the spots and add those together. So negative 15 plus 12, negative 3, negative 10 plus 0, negative 10, negative 5 plus negative 12, negative 17, negative 5 plus negative 4, negative 9, negative 20 plus 8, negative 12, 0 plus 20, 20, negative 30 plus negative 4, negative 34, 25 plus 16, 41, yeah, 0 plus 24, 24. So there we go. There's my answer. Seems simple enough. Totally agree. Right? For now. But starting off, matrices are very intuitive and the operations make sense. Right? It will definitely get more complicated, but remember these good times whenever it was just simple, didn't take too much effort or work or brain power. Oh boy. Oh boy, oh boy, oh boy. Woo woo. All right, special matrices. So we have a square matrix. A square matrix is just a matrix that is m by m. So that just means there's the same amount of rows and columns. Right? So for example, like these that we did were 3 by 3. So since the row amount is the same as the column amount, we would call this a square matrix. But it could be any number. It could be 2 by 2. It could be 10 by 10. It could be 1001 by 1001. Right? 49 by 49. Whatever. As long as the amount of columns is the same as the amount of rows. There's no limit to how big a matrix can be. Okay. Sorry. I think my microphone's getting old. It kind of, like, I'll have to like unplug it and replug it in again, but it should be good. I've had this for a long time. Okay, so there's 2 by 2 identity. This would be an example of a 3 by 3 identity matrix. Again, 1's along that main diagonal. Everywhere else is 0. And it could be any size. It could be a 10 by 10 identity matrix, a 100 by 100 identity matrix, a 37 by 37 identity matrix, whatever. Zero matrix is a matrix of any size, just where all entries are zero. Okay, that's pretty self-explanatory. So we don't need to worry too much about that. But any size except just all zeros. And then I guess kind of crooked. Because why not? All right. Square matrix, identity matrix, zero matrix. All right. And I know that was pretty short. That's where we'll pause today. Coming back next time is when we'll start to get to some interesting things. So I don't want to start those just yet. I just want to leave us with the basics and then start up the fun stuff. So we'll start off next time talking about the other type of matrix multiplication. So we already talked about scalar multiplication. So now we'll talk about what's just purely called matrix multiplication. And it's a little bit worse. Takes a little more effort, some more steps. So we'll start that up when we come back next time. But for now, let's just remember where life is easy with these matrices. You know, just kick off the weekend. I'm feeling good. I understand all the matrix stuff. I can enjoy the snow. Right? It snowed last night, right? Yeah, I think a little. I don't see snow. Like, I looked outside. I don't see snow specifically, but my mom sent me that it was snowing out at her house. Which is pretty wild. It is it's not March, you guys. It's April 17th. The perfect time for snow. Messaging too quickly, man. I know. Classic Nightbot. I mean, also here, I don't want to brag, but I'm doing all right here. Oh Lord, because you're so impressed. Yeah. I feel you. Makes sense. Sure, exactly. You don't need to put the you can just put sure. It's cool. All right. Okay. I'm gonna peace out soon. I have no, assignment for you or anything. Actually, I do have an assignment for you. Here's what I would like to do. For anybody that actually listens or watches these, whoever you are, okay. Now I would actually really love to just hear from you. If you send me a quick email that just is a hey, and just kind of a brief update of how things are going or how the online learning, it doesn't even have to be about school, but just an update on what you've been doing in your time or how you are, how's your family, or whatever you want. I just want to hear from more people because I only hear from a certain amount, right? Kyler, I appreciate it. I love talking to you every day. But I know there's got to be a couple lurkers that just sit here and watch this on Twitch or YouTube, and that I never get to hear from. But I'd like to hear from you guys, including you. Even though I do talk to you every day, Kyler, or every day in here, I still wanna hear from you as well. So I would really love that if you guys sent me just a quick email, just telling me how you're doing, just so I can hear from you. Because believe it or not, I do miss you, dorks. All right. I miss the pain and suffering that was our class in person. So, yeah, I really enjoy that. I worry about everyone, and I want to make sure you guys are doing okay. So, please do, if you can. If you have